Good evening, everyone. This is Mike O'Malley here with a severe weather outlook and discussion for January 2nd, 2022, recorded around 6:45 p.m. Eastern Time. Happy New Year to everyone. Hope everyone's holidays have gone well. Today we have the potential, or this evening rather, we have the potential for severe weather across a rather large area from the Florida Peninsula all the way through portions of North Carolina today. This is in response because we have a developing low pressure system over the next few hours that will be developing around Georgia and moving off towards the north and east. This has already brought some inclement weather yesterday to portions of the mid south and will continue to affect some of those portions today and across the remainder of the southeast United States through this evening and the overnight hours. A broad slight risk for severe storms has been introduced today. Again, the best area is going to be mainly along this corridor from Georgia in through portions of South Carolina. This is where the better low level dynamics will be, the upper level dynamics. But the main question today into tonight is going to be instability. We can see that the tornado threat here, the large 5% area from around Tallahassee all the way through South Carolina and into southern parts of North Carolina. And I do suspect that this may get upgraded within the next 2 hours to a 10% region because of the threat that there could be some stronger tornadoes tonight, mainly across portions of South Carolina. Now, why is that? Well, we can take a look here at the 18Z sounding. This is from Tallahassee, and we can tell that there is relatively decent moisture aloft. We have moisture, sufficient moisture for thunderstorms all the way up to about 3 kilometers, and we have a pretty steep lapse rate, a moderate to steep lapse rate through about the first 850 here, through about 850 millibars, or the first kilometer in the atmosphere. And then above that, we do have this little warm nose, and that's been preventing some thunderstorm development because in through here, this is the inferred parcel temperature right here. And this is the actual temperature in the sounding. And we notice that in between these two areas, there isn't really a lot of instability down here. And this has really been preventing a lot of significant severe weather because of the fact that the convection that forms down here at the surface or just about here at the LCL height and the LFC height. And convection tries to rise, and it rises freely up until about maybe 600 or so millibars, and then it starts to encounter less instability because of this warm nose, and that's been preventing some significant severe weather, but we've still seen some severe weather today out across that vicinity. Now we can see though that there is decent moisture in place, and this moisture is going to continue to increase across portions of Georgia and South Carolina tonight. We can see here that if we look at the surface observations at this point, we do have dew points across this region. We can kind of see that dew points are in the 60s, in the upper 60s across portions of southern Georgia, but generally in the low to mid 60s across portions of South Carolina. What's actually the case in here is we have this kind of outflow boundary moving through, and we can see this on the Charleston radar site, that we actually have this outflow boundary, and storms are developing along this boundary, and a few of them, like this particular one near Tillman and Ridgeland here, just to the north here of Hardeeville, is actually trying to show signs of rotation. And we can see here that again, even on the base velocity here, not really a lot here, but there is at least somewhat of a low level mesocyclone in here. And this is because that there is some pretty strong dynamics in place across this region. Now, one of the biggest things here is obviously we have a lot of convection across this area that's causing a lot of convective overturning. And one of the main problems with convective overturning, you don't get a lot of instability. And that's the biggest limiting factor this evening, is the fact that instability is going to be almost non-existent tonight. And we can see here in the surface-based CAPE from the SPC mesoanalysis, we don't even have any to really speak of down here. All of your instability is confined out here to a broad, warm, or to a relatively broad, narrow area from about Tallahassee through portions of extreme southern Georgia here. And even some of that is within the ongoing convective response here, that we have a lot of convective inhibition across this region, which is inhibiting significant convection and limiting thunderstorm development across this region. And that, in fact, is one of the reasons why we don't really have a lot of severe weather down here. This is mainly all outflow dominant here, not really seeing a lot of well developed, organized structures in there. There might be a few down there near like Lumber City and Hazelhurst across there in Georgia, but none of those seem to be real rotating storms. Maybe a few down here, but not really much at this point. And that's going to be likely the story for the next several hours. However, though, this is based on the RAP analysis, by the way. We can tell that based on the RAP analysis here, within about 6 hours or so, we're going to have that instability axis begin to surge northward. This convective rain mass will be moving eastward with time, and there might be enough of a low level response to draw up some instability in this region. If we look here at the HRRR, this will give us a better depiction of what's going on here. So we have this convective mass ongoing, and this is now approaching closer to about midnight. This is like 11 p.m. in the evening. We have a lot of convection ongoing across portions of South Carolina and Georgia at this point. A pretty potent squall line down here, but this is mainly all outflow and multi-cell clusters in this region. But we notice that after this point, this convective rain mass begins to weaken and fade off towards the east. This low-level response here from a developing surface cyclone will be ejecting off towards the north and east, and this might be able to pull in some instability as storms begin to taper off. And in fact, we can kind of see, and if we jump down here to the surface-based instability, that there is some, and we can see that right there. There's this little very narrow sliver that's being pulled northward by the surface cyclone, which is something like here. It's going something like that. And at kind of the southern parts of that, we do have a little bit of surface-based cape. Now, there's going to be a plenty shear around. If we take a look here at the ensemble here, in the 850 wind, this is the ensemble from the Storm Prediction Center, the HREF here. We notice that we're going to have a pretty strong low-level jet. This is the 850 millibar wind, so about 5,000 feet off the ground. We have just about 55 to 60 knots of low-level shear here, and this is going to be plenty sufficient for the development and maintenance of supercells, and this actually strengthens to right around 70 knots, 65 to 70 knot flow here across portions of South Carolina. Now, this is one of the things that would be very substantial for severe weather. In fact, we can go up synoptically to the 500 millibar layer in the atmosphere, and we notice right around the same time, around 6 to 7 Z, we have an approaching upper level cyclone here, this upper level trough, and this is creating a lot of energy ahead of these storms. I mean, this is, we got about 110 knot flow here over Georgia, but in the broad warm sector that we supposedly will have, we have about 90 to 100 knot flow at 18,000 feet, and this is more than sufficient for rotating updrafts. But the problem is going to be that instability. Again, if we don't really have a lot of surface-based instability, then we may not have a lot of potential for significant severe weather. Now, if we look here on the soundings, we'll try to get one that's not actually skewed here, we have a rather particularly large amount of really large amount of SRH. I mean, SRH values in excess of about 500 here, and the 1 kilometer layer and at the 3 kilometer layer, just about approaching 600. Very curved hodograph structure. This would be very supportive for some very significant long track tornadoes, very damaging tornadoes, in fact, if you could get any to form in that warm sector. But it's going to be very difficult for that to happen. Again, SIGTOR parameters are not very high. You can kind of see that they're highest around here, but they begin to kind of taper off, and that's because of that weakening instability axis. So this is going to be an overnight event. So, of course, as always, have multiple ways to receive warnings. There is a threat, too, that we could see 1 or 2 stronger tornadoes as well because of the extreme amount of wind shear that we have in the atmosphere. So if we could get any surface-based cape in here, we may be dealing with a high-end tornado threat kind of really maturing across portions of South Carolina, really from about Columbia southward. We may have the potential for a couple of stronger tornadoes, and that's where I think the better axis here of shear and cape is going to be. So we'll have to watch this very carefully. And have multiple ways to receive warnings. Of course, no weather radio. Never rely on outdoor warning sirens, and make sure that you have your smartphones charged. And again, multiple ways to receive warnings and stay weather aware. All right. With that being said, I hope you have a great rest of your evening and take care.